We are conducting an ocean acidification lab in which we demonstrate the environmental change of ocean acidification by emitting carbon dioxide into ocean and distilled water and seeing the change in pH.
The question we are asking is, how does carbon dioxide affect the pH of water? We know that when carbon dioxide goes in the ocean and it absorbs, it releases hydrogen ions, which then bonds with carbonate. Because of the buffering system in ocean water, the pH remains stable. However, if an excess amount of CO2 enters a salt water environment, it will cause the salt water to become acidic faster, because they release hydrogen ions which lower the pH.
Because of this information, we think that when we first blow in both of them, the distilled water will change color faster because the ocean water has a buffer. Once we add the carbon dioxide, then the ocean water will change color faster because the carbon dioxide affected the buffer.
This is our ocean water with a universal solvent in it. This is our distilled water with a universal solvent in it. This is our straw, our safety goggles, and our calcium carbonate. Katie is now blowing carbon dioxide into the salt water with a universal solvent. It takes 15.34 seconds for it to change pH. The distilled water takes 4.83 seconds to change pH. We now add the calcium carbonate to both solutions. After blowing into solutions, it took 2 seconds for the distilled water to change and 4 seconds for the salt water to change pH. This is our data table showing our results. The 10 milliliters of salt water took 15.3 seconds to change pH. The 10 milliliters of distilled water took 4.83 seconds to change pH. After adding 0.2 grams of calcium carbonate, the salt water took 4 seconds to change pH, and the distilled water took 2 seconds to change pH. This equation represents the chemical reaction taking place in our experiment and how it is represented in real-world ocean acidification. The CO2 is reflected by Katie blowing into the salt water, which then releases hydrogen, which decreases the amount of calcium for the shellfish. This is how ocean acidification happens in real life.
The normal ocean water pH is 8.1 and our starting pH ocean water was 9. We do not have action to the ocean, so it is not exact, because by the time we brought it back, we would bring it back, it would be neutral. The ocean water took longer to change because of the buffer, and it also decreased more than the distilled water. The ocean water needed more carbon dioxide to change, which also is why the ocean water changed more drastically than the distilled water. The calcium carbonate made the ocean water and distilled water go back to their original pH. This is because when we originally blew into the water, calcium carbonate was taken away. This is why adding more calcium carbonate made the pH go back to normal.
Our first comparison goes along with Group A, and surprisingly this group had very similar results as our findings. In the original trial without adding calcium carbonate, it took 12 seconds for the pH of the ocean water to change and 4.09 for the distilled pH to change. The data from the distilled water was within 0.07 seconds of our findings, which we can conclude shows the accuracy and credibility of the numbers. One factor to think about when comparing our data is the starting pH. For both this distilled and the ocean water, Group A had a starting pH 1 pH higher than our calculations, which is a slight difference, however it did not skew the data in any significant way.
Our second comparison comes from an experiment in third period. The main thing that stood out was what happened to the pH after the addition of calcium carbonate. In our experiment, after the addition of calcium carbonate, our pH returned back to the previous pH at the start of the experiment. However, in this group's data, we see their starting pH of ocean water at 10, and after the calcium carbonate, it was 9. The change was similar for distilled, which started at 4 and returned at a 5. While this may not seem significant, it can show how the different force of air or carbon dioxide in the experiment can alter the data.